Hey everyone, today our overview is going to be over star size, color, and temperature. You can see I have the objective put on there that will be related to the one in class, so you don't have to write this down. I did underline the Hertzsprung-Russell diagram because that is the diagram that we will be looking at in just a couple slides. There are other diagrams you'll have to know, but for today's lecture we're just going to talk about this one in particular. So the first thing let's talk about the first thing let's talk about is star color and its relationship with temperature. So you'll notice that I put up a table here. This table is available. You can copy it. It's on the Google form that you will fill out. You should be able to just copy it on your computer and print it out if you need that. If you look here, I put the table on the left-hand side. The first column is class. The class just is the letter that they've given to that star depending on its temperature. Which is in the next column. Temperature is done in kelvins, which is absolute zero scale. So you'll see the really hot ones at the top are over 33,000 degrees Kelvin. And then the very bottom one is only 3,700 degrees Kelvin. Still very hot. Remember, 0 degrees Kelvin is absolute zero. And when talking in terms of Fahrenheit, that's below negative 250 degrees. So it's very cold, and then upper Kelvin is very hot. The other thing I want you to notice is they give you the color. So what is the conventional color that we talk about? That's meaning this is the color that we associate with that temperature. So you notice class O, which are above 33,000 degrees, are blue stars, meaning that blue in this case is the hottest. You don't want to think of it in terms of color, where blues are cool and reds are hot. You want to think of it in terms of like a flame, where the blue part of the flame is hottest and the outer red part and orange is cooler. As we move down, we get the blue-white, which is class B. You keep going down: white, yellowish white, yellow, orange, and then red are the coolest. If you look to the next row, this is the apparent color, meaning that what does it really apparently look like when you go out and look at a star? Okay, so the blues look blue-white, the blue to blue-white look blue-white, white look white to blue-white, yellowish white look white, yellow look yellowish white, orange look yellow orange, and red look orange red. So a little bit of shift in what the actual color looks like. You're not really going to see a star that looks super blood red when you look through the telescope or at the sky, but that's just to give you an idea. So one more time, we really want to focus on the fact that color relates to temperature. It's the key, so you may want to write that down. Color relates to temperature. Here's the HR diagram. The HR diagram is basically what it's done is we've aligned the stars according to two axes. The x-axis running across the horizontal at the bottom, and the y-axis running up and down. The x-axis coordinates the stars according to their temperature and their class, which again are related, right? Because the color is related to the temperature, and the temperature is related to the class. So you'll notice at the very bottom down here, they've actually gone ahead and they've made a color band that tells you color, and then in that they put the letter, and then below that they put the temperature. You can see below that they've described that axis, surface temperature, decreasing going right, increasing going left. And then the stars above it are also colored that way too. If I look over to the left, on my y-axis, I have brightness. And brightness is on the scale of how bright is it compared to the sun being 1. So as you go up the scale, you'll notice it's 10 to the second, 10 to the third, 10 to the fifth. And so you get brighter and brighter and brighter. As you move down the scale, you go in the negative direction. They get dimmer and dimmer and dimmer. Note that the large stars at the top can be bright, and that the smaller stars can be dim, right? But that there are some smaller stars that are brighter than bigger stars, and vice versa. Okay, and that has to do with their size and their temperature. So so you'll look at the supergiants, you'll notice that even though red stars are cool, and the majority of them fall near the bottom and thus are dimmer, the fact that the Betelgeuse and Antares are bigger stars that just makes them naturally more bright. In the same way, you notice Centauri, which is at the top, is a very bright star, but you look down at the bottom, and it's very hot, so it's going to burn very bright. But then you look down at the bottom, and Sirius is almost the same temperature, and yet it's much, much dimmer than that star. Okay, the last thing you really need to notice on the HR diagram is our location, or the location of our star, the Sun, which is kind of in the center, lower center to the right. Okay, a couple things about it. Notice it falls along the one solar radius, meaning that's the size. So each of those lines that say solar radius, that's the size of the star. How big is its radius? It's a number 1 in brightness, because we measure all stars compared to our star. And so it's a mid-range, average brightness, average size star. And it also falls in the main sequence category. You'll notice that's the kind of band that runs from the upper left corner down to the lower right. I want you to also notice that there are 3 other categories of stars. At the top there's supergiants, and then below that there are the giants, and then below that, and the main sequence near the very bottom are the white dwarfs. Okay. So, what do you notice about dwarfs compared to supergiants in relation to their color for the most part? So look at that for a second, because that's going to be one of your questions coming up on the form you're going to fill out. So what do you see the relationship? Think about it for a minute while you wrap this up. Okay, and then finally, with the next slide is just simply, here's another one. It's just another HR diagram done differently with actual pictures of stars. And then I also want you to notice they just kind of label things a little bit different. You still have luminosity going up and down. They just put its absolute magnitude on the left this time, and on the right up and down column is luminosity, or how bright it is. And then temperature and color still run along the bottom, and they've moved the temperature up to the very top. If you have any questions, just shoot an email my way and let me know.